Dorian, read out the question, please.
There's a diagram.
Yeah. Is it supported by two or?
No, it's an airplane.
It's an airplane? In principle of moments?
Yes.
Whoa. That's different. Thank you. Oh, that's interesting. I see why you ask now. Sorry, my plane is a bit broken. Okay, so that's L1, and that is L2, and that is W. And they're both 3 meters from the center of gravity. So there's a tree here and a tree here. And L1 is 12.5 kilonewtons. And L2, oh, show that L2 must also be 12.5. Okay, fine. And the pilot wants to turn. Oh, he must make a roll. That's the wrong word. What's the word we use when the plane turns? Bank. Make a roll. It sounds like he's making a sandwich or something. Pilot wants to make a sandwich anti-clockwise. Right, so let's just do the first part. Can I hold on to this for a second? I'll just put it there. Yes. Yes. Okay. So let's get L2 first. We'll take this as the turning point. Okay. So you have L1 times 12500 times 3. Sorry, what am I saying? That must equal 3 times L2. You know, this turns clockwise and this turns anti-clockwise. And if you take that as the turning point, what? You have that face like you did something silly.
I did another one.
Did you get the right answer?
Yes.
Did you make your life harder?
Not really.
Okay, good, fine. So then L2 is the 12.5 kilonewtons then. Okay. Now, more interesting though is part B. So part B, he says he wants to turn the plane, and L2 is increased to 13 kilonewtons. And what must happen to force L1? Now, I don't think they're asking you to calculate it. Not until part C, maybe. I'm not sure. Let me see. Because the question is, well, maybe the English isn't clear. What must happen to force L1? So they might want a number here. Anyways, what must happen to L1?
Must decrease.
It must decrease.
Or it can stay the same.
It must be smaller than the
I see, I was thinking that too, but they don't. You want to make sure the plane isn't climbing or descending. So my concern, Zach, is if L2 just increases, then yeah, the plane will turn, but it might also rise. So I think L1 has to L1 is reduced.
Yeah, if the force on the airplane is to remain 0.
Yeah. Okay, part C. What is the total moment on the airplane about centre of gravity when L1 and L2 change? That's hard. Okay, this is how I'm going to do it. Can you look? Oh, come on. Right, we know that the weight is 26 kilonewtons. How do I know that? L1 plus L2 at the very beginning.
So
Oh, sorry.
15.
25. Not 26, I'm sorry. 25. And this one is 13. So if this guy increased to 13, then what is happening to this guy decreases to 12 kilonewtons. Decrease to 12. Now, all the forces are balanced, aren't they? The total up is 25 and the total down is 25. So will the plane climb? No. But now the moments aren't balanced. Yeah, the moments aren't balanced, so the plane will start to bank. It will start to rise on this side and drop on this side. But it won't go up or down. It'll just start to become unbalanced and turn. And they want to know what's the total turning force now. So this one, if we take this as the turning point, again, this one is
13 times 3.
anti-clockwise, isn't it?
Yeah.
And this one here is clockwise. So the total will be 13,000 times 3 minus 12,000 times 3, which will be 3,000 Newton meters, or 3 kilonewton meters. Oh, and we should say which direction that is anti-clockwise. Yeah, that one was a bit tricky, Dorian. That was a good one to do. That one was a bit tricky.
Also, I thought that, because it was extended like this, then we would have to, I thought we had to resolve it or something.
At the first, I thought that too, but then I realised it mustn't be this because they didn't give us the angle. So
we could just simply assume that it's, we don't have to
assume what?
assume that, that
It's level. Yeah, what I'm kind of doing is, in my head, I'm imagining the moment where the forces become different, but not enough time has passed for it to bank. So this, like, if this was a video, the moment I press play, it will begin to tip. Yeah. This is a bit tricky now, for sure. Maybe I want to put this on the exam. I kind of like it. Okay, can you write that down? If you need to. Well, I think everyone should probably write this down. How good are these MacBook Airs? How good are they? Are they good?
Oh, it's crap.
If I spill coffee on it, would it be okay?
I
Or?
already spelled Coke on it.
Okay.
But it's still because there's a plastic bag under their keyboard.
Nice.
Yeah.
That's good.
So you can feel that on the right side of the keyboard is quite sticky.
Oh, Coca-Cola. So the Coke is under the keys, and it's, yeah.
Yeah.
Now, Dorian, you said you had 2 questions. What's the next one?
I think it's circular motion.
Circular.
We actually have discussed this before, but I had an extra question.
Circular motion. Which one?
Question number 10.
Circular motion number 10.
We did this.
Did we discuss this?
Mm.
I do not remember discussing this.
No?
ID 422?
No, we didn't discuss this. I corrected it.
Okay. Don't mess with my head.
Sorry.
Right. Will we do this one? Can you look at circular motion? Question 10. ID 422. Zach, do you have that open? Yep. Now remember guys, all I'm going to do for your mid-semester is literally copy, paste. That's all I'm doing. Okay? I'm too tired and busy to make up new questions. I'm just going to copy and paste which ones I like the look of. You know. Okay, let's have a look at this one now. So the car was going over the hill, yeah? The mass of the car is 1,000 kilograms. That is one small car, right? And its speed is 15 meters per second. What type of car is 1,000 kilograms? Like one of those Soviet Russian cars, is it? Like with the 3 wheels, is it?
Yeah.
A Robin Reliant, perhaps.
Mini.
No, a Mini be more than 1,000 kilograms.
Really?
I'd say so. The radius here is 80 meters. And the question is, first thing is to draw the force, the resultant force. They don't want all the forces. They just want the resultant force. So, who can tell me where the resultant force is on this picture? Very good. Straight down towards the center of the circle. Okay.
Just in that circle zone.
Yep. What is the magnitude of the resultant force? So that's F equals ma, which equals mv squared over r, which equals 1,225 over 80. Cancel. That goes in 12.5 times. That's as much as I can do in my head. 12.5 times 225.
$2,812.5.
2812.5 newtons. So that's roughly, in the exam, you'd say the answer is 2810. So 2810 newtons. Yeah? And then part C is what's the total reaction force. Show that's roughly 7,000. So if you look at the car now, there are two forces acting on the car. Yeah? You have a weight of 1000 G, and a reaction, or, and which is bigger? The weight is bigger. In fact, 1000 G minus R should equal 2812.5 newtons. Okay? So that means R would equal 1000 G, which is 9810, minus 2812.5, which is what?
6,997.5.
0.5 to three significant figures, that would be 7,000.
So why the reaction force is smaller than the...
Yeah, who can tell him that? Why is the reaction smaller than the weight?
If the
Because then
reaction
it
is
would
bigger,
just-
then it would just.
Yeah, if the reaction was bigger, the car would start to float up. Yeah. You need the weight to be bigger to make it turn in the circle. Because remember at the beginning we said the total force is towards the centre of the circle.
Oh,
Yeah.
Oh.
Yeah. Now don't laugh, because when you drive over a bump and the car lifts off the ground, that's exactly the reaction force being more than the weight. That's exactly what happens. You know, the car comes along a speed bump, it turns around the speed bump, and then it leaves. It goes in the air a little bit. That is if the reaction was greater than the weight. That's when the car exits the circle, goes in the air a little bit. So it does happen. It does happen. Okay, what are we doing next? So Dorian, what was the problem with this one?
I got confused with the first question.
Part A. Part A. Okay. What's next? Do you need to have a look at this to see? Are you sure? You can look at Harry's.
I do have one question, but it's not that. We have those formulas for simple harmonic motion.
Yeah.
One of the questions when I had to count this, because they were looking for, I think they were looking for either T or either A,
Yeah.
and there's this cos omega T.
Yeah.
So it should be cos omega T. So cos omega times cos omega T.
Okay, I had you up until the very last part. So it should be, so we're talking cos
It's
omega t.
so it should be like that.
You're thinking, oh, it was cos omega times t.
Mm.
Oh, no, yeah. It's cos of omega t. Yeah.
So can you do question 9 of the pendulum?
Pendulum?
It's the last one, 9.
Last pendulum question. Yeah, okay. Pendulum, last question. Pendulum, please.
Over time, the amplitude of the pendulum will decrease due to light damage.
Oh, you just need me to do the last part?
Yeah.
Okay. So literally the last part of the last question. So, here's the pendulum. Now this question, I remember last year as well having a discussion with the students because it's not really clear exactly what the answer is, but let's have a look at it. So they say over time, when the pendulum swings, it will undergo dampening. Light damping, apparently. State and explain what effect, if any, this will have on the ability of the clock to keep the correct time. In other words, their question is, how does the damping process affect the periodic time? Now this is not, you think this is easy, it's not, we'll really have to think about this. So, what is happening in the picture? Well, we have the weight here, and we have the tension here, and remember we resolve the tension this way and this way. And this part only cancels the weight, and this is the interesting part. But now we have a friction. So, you proved last time that, what was it? A equals minus omega squared x, where omega was root g over L. Yeah, omega was root g over L. Now what's going to happen this time though is the A is going to be bigger or smaller. So the A is smaller. So that is like the omega is smaller. Now why am I saying that? Well, here's my formula. The x isn't really changing. Okay, the x is actually getting a little bit smaller too. So you can think about it two ways. You can think about either the x is becoming smaller or effectively the omega is becoming a bit smaller as well. It's almost like you made this smaller. It's like it has the same effect. So if you look at the formula for 2 pi root, or 2 pi over omega, if the omega is smaller, what is the effect on the t? It's bigger. Now that kind of makes sense if you think about it. The pendulum swings back and forth. Okay? If you now have a friction force, kind of pulling it back, will that help it swing a faster time or a longer time? It's going to take longer, right? You know, like think about it. If a person has to walk from here to here, it should take them a longer time to do that if somebody's pulling behind them. So I think the effect will be to make the time, the periodic time longer. Now, how does that affect the clock time? So the grandfather clock thinks maybe that each click is a second. But if it's going to take longer, then each click will be maybe 1.01 seconds. So will that make the clock run fast or run slow? It'll make it run slower, yeah. Because when the clock thinks 1 second has passed, more time has passed. So I think the answer is it's like omega decreases since the A decreases. Therefore, or that implies the t increases, which means then that the clock runs slow, which it kind of makes sense. Grandfather clocks don't run fast, they run slow when there's a problem. In fact, most clocks run slow when there's a problem. Yeah. I have no idea what the answer says, but I think they're flexible with this answer.
But they refer specifically to the amplitude of the pendulum.
Well, I don't think that is terribly relevant. The only thing that mattered in that sentence was that it's being damped.
Yeah.
And they just wanted to make it clear that you understand that the amplitude is being damped. So it's not swinging as far out left and right. Now, I know what they're going to do. What they're going to say also is, some students may argue that the time is not affected because the amplitude is not in the formula for t. That is a fair point, but they're forcing the question to be more realistic. And so realistically, the A does affect the time, it's just it's not in the formula, realistically. Your formula doesn't contain amplitude.
They don't state that the pendulum is just horizontal.
Exactly. These are assumptions. So in realistic life where there is damping, and we have to be more realistic, the amplitude should be in the formula for t, and it's only not because we are approximating. So I don't like the answer that says, oh well, the time is not affected because the amplitude is not in the formula. It's not in the formula because we didn't put it there. It should have been there. You know. So I prefer my answer. Now, do they give marks for this answer too, or are they going to be jerkwads? It was 16-17 semester 1 version 1 A7. Version 1 A7.
Oh.
What?
7? It says no effect, because amplitude does not affect t.
It's disgraceful. That's a terrible answer.
Or alternatives.
Good. Yes. Alternative. Yes.
Slight effect,
Yes.
as damping causes small reduction in natural frequency.
Yeah. Okay. So
So
that's
to say
fine.
omega is changed.
Yeah. They said Dorian that the frequency reduces, and remember we have the formula t equals 2 pi over omega, and t is 1 over f. 1 over f equals 2 pi over omega. So omega equals 2 pi f. So by saying the f is less, it's the same as saying the omega is less. So that answer matches what I'm saying, just it's much shorter. Okay, I hope that's okay, Zach. That was a very exhaustive explanation. I hope it's clear in your mind now. Yeah?
It is.
Right,
And
well,
just,
yeah.
it's so strange how the NCUK has changed how they want their answers to, like,
Well, it's only because the person who writes the exam changes.
changes every year.
So it's frustrating for me because I'm obviously the same person each year.
Yeah.
So I do the same thing, and then some new person writes the
Standards
exam.
seem different over the years.
Yeah, now MTUK's official line is, no, the standards are constant and the exam is consistent. I'm like, really? Really? Okay, fine. And I think it's ridiculous because students, they can see for themselves when they're looking at the exam that the exam has obviously gone through transition stages where 1 year there's a different emphasis on different topics and so on, you know. So I just have to pretend to believe, you know, like, yes.
People say NCUK might be subscribed to your channel.
It's highly unlikely. Highly unlikely. Like a lot of my videos I'm sure still have 0 views, so. Like how many people are going to watch this video again? Like I'm sure if I check tomorrow the view count will still be 0, you know. Unless maybe 1 view if someone accidentally clicks it, maybe. Yeah.
One of us rewatches them.
Well,
One of us rewatches them, like the class. So
you watch them?
sometimes, yeah.
Sometimes they're good.
I was checking the work on your channel yesterday, and I was searching for it, and this pops out some, like, you're doing some TV add-on.
Oh yeah, that's when I did something interesting. I made a TV add-on for Cody. It scrapes TV stations. But I had to stop doing that because I was getting unwanted attention from people on the internet. How can I describe them? They're not so concerned about copyright. So they would contact me like frequently saying, "Oh, can you write an add-on that scrapes these channels? You know, like make a pirate add-on." I'm like, no. I'm not like every week someone would email me saying, "Oh, I see that you made this add-on. Could you make this pirate add-on?" Don't want to get into trouble. I don't want BBC suing me or something. I use Python to make the add-ons. They scrape a source for the video stream. It was quite difficult to do because the source only lets you view the stations for 10 minutes. So what my program had to do was make a fake account every 10 minutes, and then you know the way you get an email sent. So then I had to use a fake email and then click the link. Then once this is done for one day, that's enough because it's 10 minutes per free trial per day. So as you're watching the station, every 10 minutes, you don't realize this, but you log in as a different user so you can continue the stream. Now you might think, oh, but does that not mean every 10 minutes the stream stops and it starts? No, because the way they made their server is they only check if the 10 minutes is up every time you play a station. So as long as you don't stop the station, you can go past your 10-minute trial. Then if you stop and switch to another station, you, in between, log in as a different user. So this is how I could get around the 10-minute free trial restriction. So I made this add-on that made it look like you could watch any station for as long as you want.
Okay.
This is what I do in my free time. Alright, what are we looking at next? Those are the two that you needed, Dorian, and that was the one you needed, Zach. Now, I'm concerned. Does the lack of questions mean that you're not trying, or that you're finding this too easy, or what?
No, sometimes we just look at the answers and
Oh, that's dangerous. That's dangerous because that might make you think you know what you're doing.
yeah.
And then when you get to try it in the exam, you realise, oh, actually, I don't know what I'm doing. Be careful with that. Yeah?
There's a question in power and efficiency
Power and efficiency. Okay.
that kind of mentions current and voltage.
Oh, that shouldn't be there then. Which one is this?
Could you try?
Question 5.
Power and efficiency. What's power and... Is power and efficiency after Lemmy?
Yes.
Yeah.
No, it's after conservation.
ID 444.
Conservation.
Thank you, Dorian. Of course that shouldn't be there because it mentions things we haven't done yet. So I'm going to move that to the electricity chapter. 444. Okay. That's grand. Right, what else do we need to say?
Number 6.
On what?
Which circular motion.
Good, yes, that's a tricky one. Number 6, circular motion. Yeah, we agree this one needs to be done. An object of mass 2.5 is attached to the end of the string and rotated in a circle of radius half a meter in a vertical plane. So it's swinging around like this in a vertical plane. So it's being swung around like this. It's 2.5 kilograms. The radius is 0.5 and the speed is 4 meters per second. And the question is, what is the max and the min tension?
Mhm.
So, when you're looking, now, you can think about this. If you imagine swinging this around, can you visualize at what part in its journey will the string be most tense?
The one is loose.
The lowest part. And the least tense will be the highest part. Now, if you think about this, why? Well, imagine you were spinning it kind of slowly.
Force of gravity and the tension.
Yeah, well, that's it. Yeah, you see, at the highest point, both the tension. Where's my pen gone? I can't see. Sorry. Both the tension and the weight are working together. Whereas at the lowest point, the weight and the tension are working against each other. This causes the tension to be greater because it has to work against the weight. Whereas here the tension can afford to be less because the weight is doing some of the job. So, we can look at the bottom first. And we can say, which is bigger, T or W? T is bigger, why?
Because it's moving in a circular.
Yeah, centripetal force. So T minus 2.5 times 9.81, that's equal to m v squared over 4. What the heck? Yeah, right? Is that right? So what can I find here? Well, I can find the T, can't I? I can find the T max. Now, let me look at the top. What is the... So, no, sorry, let me write this down. So, T max will equal 0.5 into that is 5 times, isn't it? And 5 times 16 is 80. And it'll be 80 plus...
Shouldn't be 16 squared.
It was 4 squared.
Oh,
Like that. Yeah? Now, what is the only difference up here? Well, it will be T plus W equals mv squared over 4. So when you take the W to the right, it becomes a minus W. So the only difference between T max and T min is in your answer this becomes minus. And they're the two answers, T max and T min. Okay. Can you tell me what those two are, please?
Maximum should be 100.
104 newtons maximum.
104.5 to
55.
So it should be 105 newtons
55.5.
for the
Which
min
one
one.
bigger is that?
55.5 newtons.
I rounded correctly.
Yeah, 55.5.
Oh, it's 104.5.
0.5 means round up.
I know, I rounded incorrectly.
That's okay. Right. You got that one?
Mhm.
Yeah.
Thank you.
There's time to do one more for sure.
Question 8.
Conservation of momentum number 8. Is it a good one?
What's the ID?
ID
Yeah, it is.
ID 328, is it?
Yeah.
328. I thought we did this one, didn't we? But we can do it again. That's no problem, Regina. You're my favourite student, so we can do it again, no problem. Right. Oops. Okay, so this one, what have you got? You've got a large mass here, M. Do we know what the big M is? 100 grams.
Yes.
And then you have a small mass here of
20
20 grams. And it swings down. And do you know the length? 30 centimeters.
From
Another 30 centimeters from the center of
Oh, sorry.
capital M.
Sorry, they're saying that this here is 30.
Yeah, from the center of the.
Yeah, center to center. Do you know the length of the strings? I guess you don't need to know them.
Can you just equate?
Yeah, right. So, part A, I want to know, if you can see here, look, Regina, what I want to know is what is the V here when it swings down to the bottom, but just before the collision, So what do I need here? What formula? What idea?
Half mv squared is going to be.
Yeah, what's that called? Conservation of energy. The potential energy here equals the kinetic energy here. Yeah. So that's mgh equals a half mv squared. Cancel, cancel. V equals root 2gh, isn't it? Which is root 19.62 times 0.3. Is that right? So what the heck is that?
2.43.
Give me another decimal place.
2.426.
Which roughly equals 2.43 meters per second. Yeah? B. What is the speed of the two masses after the collision? So now these two guys collide and they stick together. So there might be some Coca-Cola here and here causes them to stick together. What rule do we need now? Which one? Yeah, conservation of momentum. So M1 U1 plus M2 U2, which is minus
0.03.
no, the mass is 20 grams, isn't it? Isn't this right? Minus 2.426. Is that right?
Yes, yes.
Yeah.
The height was 3. So.
And then what happens is they stick together, so that becomes 0.12 times, let's just call it x. So they stick together and they move off with x. So if I just divide by the 0.12, I can get the x, which will be negative. What's that, please? 443, which is 0.404 meters per second. Okay? Next, see how much kinetic energy is lost. Right, so let's do this one quickly. The kinetic energy just before the collision, so before, there's only one thing that's moving, isn't there? The 20 grams. A half mv squared. Right, so when you're ready, tell me that. And then afterwards, a half mv squared.
Dorian, you do the second one.
Yeah, you've got the second one, Dorian, and then Zach can do the first one.
Oh, okay. The second one?
Yeah. There's two calculations.
Is 0.05885
joules. And then the second one, it should be less.
Well, 9.81 times 10 to the power -2.
So that's 0.00981 joules. So the percentage lost would equal 0.05885, 0.05885 minus 0.00981 times 100. So roughly, yeah,
83.2.
53.2, sorry, 83.2% lost. And finally, what happened to most of this kinetic energy? It became sound
heat.
and heat. So what was hard about this one? What confused you? What part was tricky? You just weren't sure about if you were doing it right, yeah. But you're okay now? Yeah? It's okay? Now, I'll start with you, Regina. What's your costume for tomorrow? Any ideas? No ideas. Dorian?
Maybe.
What?
If I'm lazy, I'll just put on some blood.
Oh, yeah, that's fine, yeah. Any ideas?
I was trying to get some children to come, but
Nice.
I tried.
That's the type of thing you just pick up in like deals, like the Euro shop or something, you know?
I already seen one on Tesco.
Yeah. Harry? What's your costume for tomorrow? No idea yet? Diego?
Me, myself, and
No. I want to see you dressed up as Boris Johnson.
I.
That's what I want to see. I want to see a yellow wig and a shirt and jacket.
Don't have
And,
my European flags here.
You can stick a pillow under the shirt and you can get a Union Jack flag or something, yeah? Zach? No? Well, even if you just want to go to the Euro shop and buy a mask for €1, something like that, you know, that's not going to kill you. Yeah? Alright, here you go. Thank you, Lynn.
Have you decided?
I'm thinking, I'm going to go to the charity shop.
The what?
I'm going to go to, the charity shop, like the cheap clothes shop for used clothes. I'm going to see if I can get some things to make me look like a priest. Yeah.
What?
Yeah.
Does someone dress as Galileo?
Huh?
Does someone dress as Galileo Galilei?
Yeah, we see these costumes are hard because you need like wigs and things like that. Priest is not too difficult. You just need the white collar. You need like a kind of a certain style of like sweatshirt, kind of the type that Colin wears, you know. Yeah, I go to a charity shop and get like an old rosary bead or something, you know. I think it wouldn't be too difficult to do. I was trying to convince one of the teachers to dress up as a nun as well, but I don't think they will. Right, I'll see you tomorrow. I look forward to seeing what you come as. Yes. See ya.